So I'm Łukasz.
I'm Wojciech.
And the topic of our talk is Zero to Hero, Simplified Cloud DevSecOps Transformation with CNAP. Okay, so you want to run in the cloud, but how? Once you decide to go to the cloud, there's millions of options you can choose from. A lot of them is something as a service. There is, first of all, infrastructure as a service, there is software as a service, platform as a service, there is function as a service, so you have to choose whatever, a lot of things as a service. Then you have to choose a cloud provider, so Azure, AWS, Google, and actually many others. And once you do it, you then have a host of options to choose from, vendor-specific features to use. But once you do it, you are locked into this cloud provider. So maybe that's not the best idea. Maybe you don't want to be so dependent on one of them, not to be able to move away. Therefore, a portable hybrid solution is Kubernetes. And Kubernetes seems like the world has chosen Kubernetes as de facto the platform to run applications on the cloud because it's scalable, it provides disaster recovery, it keeps your processes alive, it's cost efficient, it can scale on many cheap machines, and so on. But actually it lacks several features. And because of that, there is another layer on top, which is called OpenShift. And OpenShift is Kubernetes with enterprise editions. That makes it much easier to run real production enterprise-grade applications on the cloud. And you can say it's Kubernetes, but easy to consume, hardened, and much easier to operate.
So, as Łukasz mentioned, OpenShift is some kind of overlay over the Kubernetes, but much more advantage. I can briefly explain how does it look like. At the beginning, we have the login panel when we can connect it to our company credential. And after logging it, we have the main dashboard where we have briefly information about the cluster and about the application. So except of that, we have two main views, the administrator view and the developer view. The developer view allows you to control, mostly focus on the applications which you onboard on the cluster. And the administrator view is much more advantage. It's extended, for example, by the cluster settings and observability. So as you can see here, we could, for example, control the user management tab where we have the user roles, service accounts, role bindings. You can easily edit it or adding the new. The other tab is a compute tab where we can control the node, machine sets, automatically machine sets, for example, by setting them to automatically increase the nodes when the load is increasing in the cluster to give the proper workings of the cluster. So the other important things is the operator hub. Operator hub is the place where we can download the operators, which represents important tools such as databases and as the observability tools implemented in the cluster. So installed operators tab, there we can control already installed operators with their status and information about the version of them. So the other, as I said, it's an overlay of the Kubernetes. So we have the workloads tab when we have all necessary components connected with the Kubernetes, such as pods, deployments, secrets, config maps. So let's just test one of the features of the Kubernetes auto restarting. By deleting the pod, we can see that in less than 1 second, we are getting the new pod ready to use in the running status. So except of that, we can implement the horizontal pod autoscaler, which is the tool that automatically increases the amount of pod when the load is increasing. So as you can see here, we have one pod, and in the moment we get the second pod ready to use because of the increase the load. As you can see here, we have more than 200% of CPU usage. That's why we are getting the desired auto-scaling to up to 2 pods, which we implement here. It also works in the both way, I mean, in the increasing and decreasing. So while the load is decreasing, the horizontal pod autoscaler automatically see it, and then it can decrease the amount of pod to save the costs and save the all necessary resources.
Okay. that's good. So it's Kubernetes with very useful stuff on it, but it's not enough. We need more. We need better observability. We need better security. We need to make it easier for developers, because even though a bit easier, still requires a lot of knowledge to properly use it. We need to solve the questions of deployments, promotion, and tests. So CNAP can be thought of like a pyramid of three layers. On the bottom, there is infrastructure. What's important is that you can run it anywhere. You can run it on your own data centers. You can run it in any cloud provider. On top of that, there is container platform. So it's Kubernetes with OpenShift that runs your containers properly and handles all that nice stuff that we showed. And the last layer, pretty unique to CNAP, is software delivery factory. So on the platform itself contains everything that you need to build, test, scan, and promote your applications. So the main idea of the design of CNAP was that not to be dependent on any particular cloud provider functionality, always to be able to take your stuff from one cloud, move it to another cloud, or take it from the cloud and put it in your basement, just not to be locked into a specific vendor. So Software Delivery Factory provides everything that you need for building and promotion, so all the processes are built on top. So once you go to CNAP, then the only thing left for you is to write your applications, because the only thing that you need is just an application. Once you hook into CNAP, then you can just follow the guides, follow the process, and you'll be good. So it takes a lot of problems away from you. Okay, let's say we convinced you, you want it, and now what? So in CNAP, everything is managed from a central cluster. We have a central cluster called hub cluster, and each of the clusters that's actually running customer workloads is called a spoke cluster. It's a hub and spoke topology. So first of all, from this view, we claim a cluster, which means we take a cluster and start to manage it. So when we do it now, you see claim. So now an OpenShift cluster, a plain OpenShift cluster, now is being imported to our hub cluster. You can see it here, it's importing. And once it's imported, then the provisioning installation procedures start. Because here we have plain OpenShift, but now once we start to manage it, then we start adding required software on top of it. So when we go to this cluster, you see immediately after this importing, crucial core operators are being put on top of CNAP, on top of OpenShift, which starts configuring CNAP OpenShift to make it to add the functions that we need for CNAP. One of these operators is OpenShift GitOps, which starts the second phase of provisioning, and the provider is Argo CD. So let's go to Argo CD, and you will see what happens. So we go over there. There is Argo CD. We log in first time because it was a completely fresh OpenShift cluster. And now we pointed Argo CD to one repository called CNAP Components, and inside there is it's actually a parent application. And you see it exploded into different applications because this pattern is called app of apps. So we point Argo CD to this parent, and parents contain children, and each of these children is a component that we use in Software Delivery Factory. So this means everything that you need is being put on top of the cluster. So the pipelines, scanning tools, image repository, everything now is being automatically installed, and you can track the progress from here. So you see some of them become synced, they are progressing, and this process normally takes about 10 minutes. It's sped up for this demo, but you can see now everything is done. So in this way, we fully control the state of the cluster in Git. So it's even provisioning is fully GitOps, which means you know exactly what you have on each cluster. As you can see, everything turned green, and now it's ready to go. So all set. You have your cluster ready. And now what?
While we have our environment ready, we need to focus on our application. So at this moment, few steps are done manually, such as configuration, pipelines, and repositories. But in the future, everything will be done on the GitOps way. So everything will be automatically settings by pushing the commit to our GitHub. But don't forget about the security. Security is very important nowadays, so that's why we implemented 3 main layers of the security, like code scanning, dependency analysis, and container security, which are all available in our pipeline, which I will show you now. So I would like to show you briefly this description about the onboarding new application on the cloud. So let's start from the login to the OpenShift. So as before, we are using our company credential to log in. And then we see the main page. Let's go directly to the root where we have exposed our URL address, already deployed, already onboarded application. We can just copy it. And as you can see, our test application is very simple. It has one endpoint which returns you the hello message. So let's go to the Postman software to test it by pasting the URL address and adding the endpoint. And we can execute the GET request. We get the message hello. It means that our application is properly deployed on the cloud environment. So let's just modify the app by changing the return message. For example, welcome Tech Summit 2023. We will have the new version of our app, and just what we need to do is make a commit. After pushing the commit to our GitHub repository, everything starts automatically. So let's come back to our OpenShift cluster. Let's see the pipelines tab, and let's wait a few seconds for the pipeline. And as you can see, the new pipeline has started. We can go into it and see the details view. On the top, we have the name of it, and below, there are all steps implemented in our pipeline, starting from the configuration, going through all security layers, and finishing on the building and uploading the image to our cluster. So as we mentioned before, we have 3 main security layers. And the first one is on the code analysis step. Let's just wait a few seconds to see it. Yes, and we can see the Sonar Cube. So the Sonar Cube is a static code analysis tool that helps detect dangerous code and code smells, including security bugs during the development process. So on the main view, we have all applications implemented on the cluster and the briefly description about the bugs, vulnerabilities, and detected issues. So while we're going directly to our application, we have more precise information about the detected bugs. In the Issue tab, we have listed all detected issues. By clicking on one of them, we have the data about where the issue was detected and the description, how the issue was detected and why the issue was detected and how to fix it. So, except of that, we have other important information in SonarCube based on which we can analyze the bugs, we can fix them, and control the activity of the process of detecting them and fixing them. Like in here, we have the activity chart where we see all detected bugs. So the other important tab is a quality gauge where we implement the threshold of the test coverage and the duplicated lines. It is necessary to set this threshold to pass the step while we're going through the pipeline. So as you can see here, the code analysis step finished. We get the green result, and now we have the second layer of the security represented by the dependency track, which is the tool responsible for monitoring your project dependencies and libraries for known vulnerabilities. So the main view is quite similar like in SonarCube. I mean, we have the general information about the detected bugs in whole cluster. While we go to the project tab, we can choose our project, and we have detailed information about about detected issues. So we can go to components tab where we have listed all components with their licenses and versions. After that, we have the dependency graph. We've listed all dependencies where we can in easy way see the connections between the dependencies. This other path is vulnerabilities detected. We can find the severity of them, like medium, risk, or low. We can read why the issue was detected. And if we mention that it's not the issue, or we can just change the status of them. Sonar dependency track allows us also to connect it to our email address, Teams or Slack, to be informed live while the issue was detected, so we can modify them in fast way. So the last part is the policy management, where we can implement our own policy based on the requirement of the project. We can edit it and control in the easy way. So after we finish the second layer of the security, there is a part mostly focusing on the building image and creating the release. So as we can see here, we're creating the repo where the image will be uploaded, and the step focusing on the building the image. In this step, we build the image and then we push it directly to our image repository. In this case, it is QA. After push it to the image repository, there is the last third layer of the security represented by the ACS. So the Advanced Cluster Security is a tool designed by Red Hat, and is an image-level security tool that helps secure your containerized application. So the ACS provides visibility and control over the security of your container images, helping to identify and prevent security risk at the image level. So the view is quite similar like in the previous two applications. We have general overview about the detected issues. We can see which is critical, which is medium, which is high. And then we can, based on the information, we can fix and prevent in the future. So while we have analyzed all the application, we are ready to onboard it on our cluster. So just few steps left connected with the uploading the image results, image check results, dependency track assets. And now we can see that all steps are green. We get the succeed status. It means that our pipeline finished properly and we are ready to use the application in the cloud environment. So as you remember at the beginning, I changed the message, the Welcome Tech Summit. So let's just check it by executing GET request. We get the Welcome Tech Summit message. It means that our application works properly on our cluster. So let's just check last things. As I mentioned you before, we upload some results on the GitHub. So let's go to the GitHub. Let's see the application. We see the release 3 minutes ago. We can click on it, and we have all available data about the scanning results from the dependency track, for example, from the image check results, and all are available in one place in GitHub, where we can download it to our computer and analyze them in the future.
Okay, so now we know that the application has been built and deployed to the cluster. But what exactly? This is a development environment. And now the question is how to safely move the application from the development environment up to production environment through different stages, and how to incorporate tests during this process. So going back to GitHub, you see there's this new version 1.0.33. And let's issue the GET request again, and we see that Welcome Tech Summit. So we know that it's running on the cluster. Now let's go to OpenShift, and you will see that we have 4 environments. We have CNAP environment dev, test, staging, and prod. For this presentation, all of them are on the same cluster. However, production environment normally is elsewhere, not to make it as stable as possible, because remember that the dev cluster also is responsible for building, so you don't want to interfere. Number of environments, number of clusters, it's all up to the project. We start with 4 because this is the best practice, but if project requires that, it can be different in every case. As provisioning, deployment is also done using GitOps approach, which means that every environment has a corresponding repository. As you can see, there is dev, test, staging, and prod repositories. And the way it's done is that Argo CD is observing this repository, and whatever it finds inside, it deploys to the corresponding environment. So let's focus on our application. This Synapse Poco 1 new, that's the one that we are working with. And you can see that it's Argo CD specific things, but what's important is that the version is 1.0.33. This means that on the dev environment, 1.0.33 is running what we have seen when we issue the GET request. But now let's see the second environment, second in line, which is test. And if we see the test environment, the application is also running there, but has a different URL. So this could be a different cluster. It has a different URL. We have it here. You see it's in the name, actually. That's by default. OpenShift gives you this, gives the name of the project in the URL. And when you issue the GET request, the response is hello. So it means that on the test environment, we have a previous version. Okay, now let's go to GitHub. So you see under the hood what's happening here. When you go to the test environment, it's also our application is also listed here. And the version that's shown is 1.05. Okay, so because it's GitOps, we have to think about promotion a bit differently than normally. Since everything that's here is deployed to the test environment, it means that we have to change this version in the file. And in Synapse, it's done using pull requests. Pull request is opened automatically by Synapse. It detects a new version was pushed to original repository and creates this pull request over here. So there's promote Synapse Poco 1 Java Maven new from 1.05 to 1.0.33. And that's exactly what happens. So promotion is happening on the GitHub part. And then it's detected by, we don't do it directly on the Synapse, but you do it on GitHub. And therefore, promotion, so deployment, is actually merging this pull request. Once I merge it, you will see the changes that are actually part of this pull request. So when you go to the files changed, you will see that it's in the end very simple, but it's automated, so you won't make a mistake. 1.05 to 1.0.33, that's the change. And now this can be pretty confusing at the first thought because it's GitOps and it changes the way you think about it. But because of this approach, because of pull requests, we get out logging for free. So we know, because GitHub keeps track on the pull requests and comments and merges and everything related to them, so we know exactly who deployed what, where, and which version to which environment. Everything is here. Second, since every environment is a different repository, it's very clear how to configure security for them. Whoever has access to merge pull request on a given repository can actually deploy stuff on this environment. So you can have different people, let's say developers, being able to deploy to the dev and testers to test, and maybe only a few people to prod, or maybe you want to change it and make everybody able to deploy everywhere. Second thing is that we have integrated tests into this release process. You can see there is a file. When you download this file and open and check what's inside, you can see it's results of a testing framework called Robot Framework, and this particular framework, Robot Framework, it creates a report like that, and you see there's one passing test case. And also, going back to GitHub, you will see that the test results are also attached to the release. So when you go back, you see the thing that Wojciech showed, image check results, and also test results are part of it. So from GitHub source, you know everything that happened to this release, and you can trace it throughout the life cycle. Okay. Okay, so now let's merge it. When I merge this pull request now, confirm the merge. Now, a version changed in the repository, which triggered Argo CD to detect, there is a new version, so then Argo CD is doing and deploying this to the correct place. And when issuing the GET request again, on the test environment, you see that there is Welcome to Tech Summit 2023, which means that our application, the same image that was built, because image was not built again, the same image was moved from one environment to another. And now what? Once it's on the test environment, now it's time to go to the next one. So another pipeline starts that will repeat the process for the next environment. And here, it's important to mention a couple of things. First of all, we support different testing frameworks, basically anything you want, because the way we designed it is that you use a container, and any container you want to add that can run on OpenShift can execute your tests. You basically specify it as one of the properties file in your application. So any testing framework you want can be integrated. This is a robot framework, but also we have worked with Selenium tests and we have worked with Yax testing. Basically anything that can run in a container can be incorporated in the process. Also, there can be different kind of tests for different lifecycle stages. So maybe you want to have your load testing on staging, or maybe you want to have penetration testing on test or whatever. You can basically configure it the way you want, so you can change what happens at which environment. And with that, you know that our application passed security scannings, dependencies are safe, the image container is safe, it was deployed successfully a couple of times during the lifecycle process, it was tested automatically, manually, however you want. And with that, welcome to production in the cloud.
So, except of that, please remember that we show you only the briefly description about what we have, and it's not the everything. So we have also preview environments, test containers, observability, wire mock, and the advantage of cloud that it also can be still developed and still implemented new tools which can be helpful in the cloud environment. Thank you.